Seema, is the rest of them joining?
Only 4 are there, na?
Only 4 are there.
Okay. And the list is for 1, 2, 3, 4, 5, 6, 7, 8 candidates. Okay. Let's start. I will check.
Okay, fine.
Okay.
Yeah.
Yes, recording is there. No problem.
Yes. Okay. So, hi guys. So, today we are starting with the data science module, right? So, I don't have any new phases here and you all are familiar with me now, right? So, let's start with our new module, data science. So, in our first session, I just gave you an overview of what data science is, what all we will be discussing in our course, etc. Right? So, what is data science actually? Remembering what is data science? What is data science? Or machine learning when we say? What is your understanding? Yes, anybody?
It helps to predict the data through algorithms.
You have a understanding or you can make your predictions using the data, and for making our predictions we have various algorithms ready with us, correct? So machine learning, as I said, it's classified majorly to 3 classes. You have supervised learning, unsupervised learning, and reinforcement learning. So in our course, we'll be looking to the supervised learning algorithms and unsupervised learning algorithms. So what's the difference between supervised and unsupervised learning? Supervised, unsupervised, what's the difference? What's the difference between supervised and unsupervised learning? So if we talk about supervised learning, in your data set, you will have your desired output as well. Or we will say that in supervised learning, the data set is, we will say they are labeled data set that you have. So you are very clear from the data set like what your output is going to be. What you have to make, what kind of predictions or what are you going to predict? So that is very clear from the data set. What is your prediction? For example, if I say a data set of, let's say, what to say, pass or fail data set of students. So you have the marks of the students available with you, and you know what is the cutoff for a student to be said pass or fail. So in the data sets itself, you have the data, what that is your output is also available in your data set. Whereas in the case of unsupervised learning, you cannot make out your output. That is, output is not present in your input data set. So there we proceed like clustering techniques, mainly we say. So what clustering is means, it's like grouping of data. For example, categorizing your data. Let's say we have a group of customers. You have to categorize them based on their preferences. So let's say a group of customers who prefers vegetables, a group of customers who prefers on like grocery items. Like that, you can categorize your data. So in unsupervised learning, we say the data are unlabeled. Or you don't have labeled data set in the case of unsupervised learning techniques. So all these algorithms, what we are going to use with supervised or unsupervised learning, the implementation comes with Python. We are going to implement all these algorithms, all these data analysis techniques, everything, the implementation or the tool that we use to implement them is with Python. So we have already discussed the basic concepts of Python, right? We have seen what Python is, what are the features of Python, right? How to work with Python, what are the basic tokens that you have with Python, how to handle variables, the data types, functions, all these basic concepts related to Python we have already discussed. Now, what we will do here is, before we start with the data science algorithms, before we step into machine learning, we will have to look into few more concepts with Python. That is, we have few modules which we use to analyze our data, to visualize our data, to do some mathematical computations, etc. We have few supporting modules from Python. So first we will familiarize those modules like we have Numpy, Pandas, then Matplotlib, scikit-learn, etc. etc. So first we will finish off all these modules in Python and then we will get started with the machine learning part. So first the course flow will be like this. We will finish off the Python stuff. That means these modules, whatever I said, and then we will start with the statistics part. We will look into the statistics, what all basic statistics you have to know to help in analyzing your data, to do the predictions and kinds of things. So that statistics will be completed and then we will start with the machine learning algorithms. Is that fine? Okay.
Yes, ma'am.
Oh, okay. So let's get started with the Python part. Let me share my screen, okay? Is my screen visible?
Yes, ma'am.
Okay. So we'll begin using working with the Jupyter notebooks. So I don't think I'll have to introduce this again to you. So let's get started. Let's first discuss about the Numpy package or Numpy module that you have in Python. So Numpy is a module that is inbuilt in Python, and this is mainly used for doing mathematical computations. So when I say mathematical computations, it's like something other than your basic arithmetic operations, what comes to our mind first. It's something above that when you have to perform some complicated mathematical operations. For example, if you have to compute the cosine of a data, that is trigonometrical operations, and some higher kind of mathematical computations if you have to perform, you can take the help of the NumPy module. So NumPy is basically used to perform mathematical computations. So it is something more advanced than your addition, subtraction, etc. And this module, when you have to perform mathematical, higher advanced mathematical computations, this module usually comes with functions like cosine, that is trigonometrical functions, then exponential, square root, etc. On top of this, we can use your NumPy to generate samples from many types of random variables. For example, when you go for data analysis, you will have to do some analysis before applying your techniques to your actual data set, you can do some sample testing. So if you have to generate some sample values, again, you can make use of the NumPy modules. And NumPy also has powerful data types like they have vectors, matrices, tensors. So before going into details of this data types, I would like to know what the difference between a vector, a matrix, and a tensor is. These are basically the data types that is available with your NumPy. So what do you mean by a vector? What is a vector? What is a vector? Okay, tell me about matrix. You'll be knowing about matrix, right? What's a matrix? What is a matrix?
2D array, rows and columns.
Correct. The arrangement of your data in the form of rows and columns. This is what we call as a matrix. So if I say, if my A, I'll call it as A. If I have the elements like this, I'll say the data 1, 2, 3, 4 is arranged in a matrix format. I have rows and columns here. I have 2 rows and I have 2 columns. The element 1 is present in the first row, first column. Element 2 is present in the first row, second column. 3 is present in second row, first column. 4 is present in second row, second column. So my elements or the data that I have is arranged in the form of rows and columns. So such kinds of arrangements of data is what I call as a matrix. Now, what is a vector? So this is of the form, I will say R by C. When I say R by C, R is referring to the row size and C is referring to the column size. So for example, if I say 3 cross 3 or 3 by 3, this says that your matrix has 3 rows and 3 columns. Right? So the arrangement of data in the form of rows and columns is what we call as a matrix. Now, what is a vector? Vector is also the arrangement of data in the form of rows and columns, but then you will have only one row and multiple columns, or you can say multiple rows and one column. Or you can say like if it is, sometimes you can even see the elements in the form of 1 cross 1. This is what you call as scalar. If you have one row and one column, it's a scalar. If you have one row and multiple columns, it becomes a vector. Or if you have multiple rows and one column, it's again a vector. For example, if our data is arranged like 1, 2, 3, this becomes a 1 cross 3 vector. You have one row and 3 columns. If the arrangement was like this, 1, 2, 3, this is called 3 cross 1. This is also a vector where you have 3 rows and 1 column. So a vector is wherein you arrange your data with either one row and multiple columns, or you say multiple rows and one column. That's a vector. Now, what is a tensor? Anything with more than 2 dimensions. That is, matrix is 2 dimension. You have rows and columns. More than 2 dimensions, we call it as a tensor. For example, arrangement of data like 3 cross 3 cross 2. This is, we call it as a tensor. Higher dimensions, we call it as a tensor. So scalar is if you have one row, one column. Vector is if you have one row, multiple columns, or multiple rows and one column. Matrix is if you have rows and columns. And tensor is more than 2 dimensions. We call it as a tensor. Is that clear? So with the help of these data types from Numpy, this Numpy also helps us to do from linear algebra some matrix multiplication. When I say linear algebra, it is the operations with respect to matrix that we do. You can perform the addition of matrices, then multiplication of matrices, then you can add a scalar with a matrix, etc., etc. So all these operations are also supported. That clear? Following me?
Yes, ma'am.
Yeah, please note down these points. What a vector is, what a matrix is, what a tensor is. Noted? Noted these points?
Yes, ma'am.
Okay. Now, if you have to work with any modules, any external modules, you have to first import the same, correct? We talked about the importing of modules in our Python class. So how can we import the module NumPy? How can we import the module NumPy?
Using import keyword.
Correct. Yes, import statement. Yes, you'll have to use the import statement. Import the module name as NumPy. So this NumPy is a huge name, correct? So whenever you're using some functions or data from this module, you'll have to use it like NumPy dot. So to that is it's okay. This step is really it's just an optional step. If you don't want to use it as NumPy, you know how we can rename our module name. So let me say that the NumPy I'm going to use here as NP. You can use any name. You can rename the NumPy module to any new name if required. You can use any short form so that it is easy for you to work with in your code. So this is the first step that you have to do if you have to work with NumPy. Import the NumPy module. So as NP is optional, it is up to you. So if you are comfortable using NumPy everywhere, it is okay. Or you can rename it to any short forms. Correct. So do this. Go ahead and import the NumPy and let me know if it is supported for all.
Done, ma'am.
Oh. I'll show you a few examples using NumPy to perform few mathematical operations. Display the result. So I have used print. Suppose if I have to check the cosine of any particular value, okay, from NumPy. That means NumPy here it is NP now. So I will say NP dot. I have the method cos. I will call cos. And let's say I want to compute the cos of pi. So again from NPy, I can call the pi. So print NP dot cos of pi. This will compute the cosine for pi. What is cos of pi? -1. And that's being displayed here. Please execute and see. You can check any values, okay? Cosine of any values you can give. Let me know if you have verified.
Done, ma'am.
Now, suppose if you have to check the square root of a number, you'll have to say NP dot, you have the method sqrt. Sqrt will find the square root. Square root of give any value. If I say 1.21, This will compute the square root of 1.21, that is 1.1. So these are few examples. As we proceed, we will see more mathematical computations. Let me know if you have verified.
Done, ma'am.
Okay. Now, let's see how we can create vectors. Let's see about the vector. So what's a vector? What's a vector?
Multiple rows and one column, or a vice versa.
Correct. So to create vectors or handle vectors in NumPy, first we have to create a NumPy array. NumPy arrays are used to create vectors. So what NumPy arrays is, you have an inbuilt function called as array from NumPy module or in NumPy module. So we will call or we will access the NumPy arrays. So there are multiple ways by which you could create it. So the method that we are going to see here is, we will be creating a NumPy array by converting a list. So we are going to create a NumPy array by converting a list. So what's a list? What's a list? What's a list? What's a list? What is a list?
Collection of elements separated by comma.
Collection of elements separated by comma. Then what else you can add?
List is mutable.
List is mutable. Then it's a sequence data type. Right? So what we're trying to do here is, the sequence data type list is getting converted to array data type using NumPy. So to access the modules of data from NumPy, we'll have to use or say np dot, I will call the data type array. np dot array. Now, as an argument to this, let me pass a list with elements, say 1, 2, 3. If you check the type of V, it is a NumPy n-dimensional array. Right? If you display your V, you could see the elements 1, 2, 3. So this is a vector. You have 1 row and 3 columns. So it's in the form of 1 cross 3. So this is a vector. So this is how you create vectors in NumPy. Execute and see. So we have created a NumPy array using list. So this is a vector. Isn't it? I can call it as a vector. Verified?
Yes, ma'am.
Okay. Now let's try creating a matrix. So what's a matrix? What's a matrix?
Rows and columns.
If you have more than one row and more than one column, we call it as a matrix. So using the array, we can create NumPy arrays, we can create matrix, and we can create it using list itself. But then we will have to use list of list, nested list. Using nested list, we can create a matrix from the NumPy array. So how can you do that? So let's call this as matrix. np dot, I will say array. As an argument, instead of passing a single list, I will pass what? Nested list. So remembering nested list. If I display my matrix, this is a matrix. I have 3 rows and 3 columns. So from the list, I have created a NumPy matrix, I will say. So if you have to create a matrix to NumPy array, pass a nested list as an argument. Please verify. So we have created a vector. We have created a matrix. What do you mean by transpose of a matrix? Yes?
No, I was just saying done.
Okay. What do you mean by transpose of a matrix? What is transpose of a matrix?
The rows become column and column become rows.
Correct. Yeah. So we have our matrix mat. We have 1, 2, 3, then 4, 5, 6, and 9, 0, 1. If I take the transpose of this matrix, transpose means interchange between the rows and columns. So transpose of this will be what? First row becomes the first column. So this is my first row. It becomes the first column. Second row, this becomes the second column. So I have 4, 5, 6. My third row becomes the third column. 9, 0, and 1. This is the transpose of a matrix. So let's compute the transpose of this matrix using NumPy. That is, I just have to simply say, let me display the result. I'll have to simply say to which matrix I'm computing the transpose. My matrix mat. I have to simply say dot capital P. This will transpose your matrix mat. Can you see? My first row 1, 2, 3 is the first column now. Second row 4, 5, 6 is the second column. Third row 9, 0, 1 is the third column now. The transpose is used to interchange the rows and columns of a matrix. Please verify.
Ma'am, that T is a function.
Yeah, it's an attribute. It's not a function. We call it as an attribute.
Okay.
type of math. It's also a NumPy n-dimensional array. So after performing the transpose operation, okay, after we have performed the transpose operation, if we check the actual matrix, the actual matrix is kept as such. You're not changing the actual matrix. The transpose is done and the result is displayed here. So when you perform the transpose operation using the attribute T, the actual matrix is maintained as such. It's not changing the actual matrix, right? The result is reflected. It takes the transpose of the matrix and that result is being reflected here. There is no change to your actual matrix. Is that point clear? Fine?
Yes, ma'am.
Okay. Okay. So this is one way of creating your NumPy arrays by converting your list. There are other ways by which you can handle the NumPy arrays. That is, we have seen about the range method, right? What was range method doing? What was range method doing? Range, if I say range of 0,5.
It will create sequence of numbers from 0 to 4.
Yeah, it was creating a sequence of values from 0 to 4. Same way in NumPy, we have a method called as a range. A range will create a NumPy array with a sequence of values. So let's see, for example, let me take the result to a variable v2. If I say np dot a range, this is called as array range. If I give a value 0, 50. Let me just display my v2. So can you see the elements 0 to 14? If you check the type of v2, it's a array. So we can say that v2 is a NumPy array which is generating a sequence of values from 0 to 14. And this v2, I can call it as a vector because it has only one row and 15 columns. Right, so v2 is a vector that we have created here, and this vector is being created from a sequence of values ranging from 0 to 14. So the function that we use here is a range, array range. Okay, please verify. Verified?
Yes, ma'am.
Yes, ma'am.
Ma'am,
Yes.
so 0 to 15 is the elements of an array, okay?
It's an elements of your array. 15 is not included. It will have values from 0 to 14. The element 0 to 14. It's a vector that you have created here whose elements are from 0 to 14.
Okay, ma'am.
Suppose if I was creating my array like this, let me say 3, 21, 6. In the earlier case, I had only 2 arguments to arrange method. Now I'm giving 3 arguments. What do you think the output will be? So again, V3, I can call it as a NumPy array I will say it's a vector that is being created here. So V3 is also a vector. What about the elements of your vector? In the first case, we had only two values, 0, 15. So as we have seen that the elements are from 0 to 15. What can you say when we add a third argument? 3, 21, 6. Six, the third argument is the step size, we will say. 3 is the first element, the starting element. Then it takes a step size of 6. That is 3 plus 6. The next element will be 9. 9 plus 6. The next element will be 15. And the upper limit what we have given here is 21. So it will include all the elements which are less than 21. 21 will not be included. So 15 plus 6 is what? 15 plus 6 is 21. So 21 is not included. So it will stop up to after 50. It will not include 21 in your array. So the third argument, if you find the third argument for the arrange method, it is your step size. And the second value here is the limit, and that limit is not included. First is the starting element. So np.arrange of 3, 21, 6, it generates or it creates a numpy array. It's a vector here that we have created with the elements starting with 3 and ending with 15 because the step size is 6 and 21 is not included. Please verify. Verify with a different step size as well and see if it's working.
Ma'am,
Hmm.
can you explain it again? I'm getting
Let
confused.
us. Okay, that does. The first number always for arrange, right? This is your starting. So start with 3. The third argument, this is your step size. So step size is what? 3. Step size will determine your next number. So step size is 6 here. That means the next element will be what? You add a 6 to 3. So what is 3 plus 6? 9. Correct? The next
Yes.
element will be what? 9 plus 6. 9 plus 6 is 15. The next element will be what? 15 plus
15
6.
plus
That is
6, 21.
21. But 21 is not included here. This is the end value. End value is not included. End values are always excluded. So 21 is not included here. So your vector elements will be 3, 9 and 15.
Okay, ma'am.
Suppose if it was like this, 2, then say 10, 3. What will be your vector elements? We start with 2. Step size is what? 3. So 2 plus 3 is 5. Next element, add a 3. 5 plus 3, 8. Next is what? 8 plus 3. So 8 plus 3 is 11. But 11 is going out of the end value. So 11 is not included. You will have the elements 2, 5 and 8.
Okay.
Yeah. So you can create Numpy arrays from list. You can use arrange method. There is one more method that we will see. So have you all verified this arrange method? And let me know if you all are clear with arrange method.
Yes, ma'am.
Okay. The next method is, you have another method like arrange. You have something called as linspace. Suppose if it was like this, let me call it as V4. V4 is equal to np dot linspace. If I say 0, 5, 10, I'll display this result for you and then you have to tell me how linspace is working. These are the elements that I'm getting. What can you say about the behavior of linspace? So it's again a vector that is being created here. So linspace also creates a vector. What can you say about the elements of this vector? So I will say that 0 is the starting number, 5 is the ending number. So here 5 is also included. The ending number is also included and you have 10 equal divisions. 10 is the number of elements that you want. And I'll say the numbers from 0 to 5 is equally divided to 10 parts. You have 10 equal parts with numbers ranging from 0 to 5. It's like 5 chocolates are given to you and you have to distribute it equally to 10 kids. So linspace generates a vector with the elements, like if you have given 3 arguments, the first argument is the starting number, second is the ending number, so ending number is also included here, third is the number of divisions that you want. So it divides the numbers into, in this case, 10 equal parts, isn't it? You can see 10 elements here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the numbers from 0 to 5 is equally divided into 10 parts. Is that clear? Following?
Yes, ma'am.
Okay.
Ma'am, I did not understood how this, like how it divided it into 10 equal parts.
Sorry, I didn't get. I can't hear you properly.
Hello.
Yes, yes, tell me.
Ma'am, I did not understood how it divided. Like from 0 to 5, it's dividing numbers into 10 equal parts.
Huh.
uh, means 0.
Hmm.
Like
So
I
what
did
is the
not.
step size here? You check the step size. 0.55 minus 0.
5.
So 0.55 will be the step size.
Yes, 0.5.
Hmm. So like that, there is a formula
Then
for
it's
that.
yeah. Also like then it's adding 0.5 after
Yes.
0.5.
Yes, step size remains the same. If the step size is same only, we can say it's an equal division, right? So if the step size
Yes.
is 0.555, so first element it is 0. To that we added 0.55. So you've got 0.55. Then 0.555 plus 0.555. So you will get approximately these values. So again to that you are adding 1.111 plus 0.555. So the next element you will get.
Okay.
Right?
Yes. Okay.
Okay. So these are the various methods by which you could create your NumPy arrays. Now let's see other
No, ma'am.
manipulations. What? Yes.
It's from for second time it's adding like every time it's adding 0.5.
0.55556. See, slight variations will be there. Some point values difference will be there. Okay.
Yes.
Okay. Right. So now let's see the manipulations what we can do with these arrays. So we can create the NumPy arrays using list. We can create it using the arrange method. We can create it using linspace. Now let's say we have this vector v4. Reshape your array means what? So if we talk about v4, how many elements are there in v4? How many elements
10.
are there in V4?
10.
10. So when you reshape your array also, the number of elements should remain the same. That means V4, I can reshape it to 1 cross 10 or 10 cross 1 or 5 cross 2 or 2 cross 5. I can reshape my V4 to all these forms. So when you reshape your array, the number of elements should remain the same. I cannot reshape V4 to 2 cross 3. I cannot do this. I have to reshape the elements by maintaining the total number of elements, or the total number of elements should remain the same. Right? So let's see how we can reshape an array. For this, you have an inbuilt function called as reshape. For example, let's try to reshape our V4 itself. If I say, let me display the result. Print V4 dot. V4 is the array that I'm going to reshape. So I'll say V4 dot reshape. Argument to reshape method, I'll have to specify the new row size and column size. So if I have given 5,2. Now presently V4 is 1 cross 10. So that vector is now being changed to a matrix when I say 5,2. So can you see the elements have now changed to a matrix. V4 I will say when I reshaped 5,2, it has become a matrix with 5 rows and 2 columns. So how is it taking the elements? It starts with your first element here. How many columns we want? 2 columns. So the first element is into your first column. Second element is into your second column. So the second column size is done. So by default, the next element moves to the next row. So 1.11 and 1.66 into your second row. Then 2.22 and 2.77 into your third row. Like that it goes. So you can reshape your arrays using the reshape method. So what you have to take care here is the number of elements should remain the same. If your original array is with elements 10, in your reshaped array also, the number of elements should be 10. It should not be greater or it should not be a less. So please verify. So after reshaping, if I display my vector V4, here also, you can see that the original matrix is kept as such. It is taking a copy of the original matrix and onto that array, the reshaping is happening. So reshaping will not reflect onto the original array. Original data is kept as such. A copy of your original data is taken and onto that copy, this reshaping is happening. So original array is kept as such, it's not modified. So note down these behaviors, okay? So once you have verified this, create a 3x2 matrix and reshape it to a vector. After you have verified this, create a 3x2 matrix. Any method you can use to create your matrix, create a 3x2 matrix and reshape this to a vector, let's say 1x6. Try to do this. Create a 3x2 matrix and reshape it to a vector 1x6. Those who have done, share your codes, okay? We will be looking only at the artifact project as well. That it should be fine. Create a 3x2 matrix and reshape it to a vector, 1x6 vector. So the number of elements are the same here, right? For a 3x2 matrix and a 1x6 vector, the number of elements are the same 6. So you can reshape the same. Okay, 1, 2. Okay, Netra. Fine, Disha. So this is the SOW that I can see from now.
Ma'am?
Yes.
Due to power cut, I'm actually attending the call through phone, so won't be able to put the code here.
Okay, no problem. You can just write the statements. See, you don't have to execute it, but as you know how it works, you can put those lines of course.
Okay.
Those who have completed, please submit your codes.
Even though this date has been mentioned, I have a mail from our homeopathy stating that this can be 31st of December because some of them, for example, even though this was planned, this has not yet come to us. There are this.
Fine, Namrata.
Starting from ML3 to ML7, we have not yet started and no inputs are being. So there's a mail which states that we can move all this to these two milestones have been completed. ML1 and ML2. These two milestones have been and as of now,
Dheeraj, Swati, what is your status?
We just are in the phase of starting that. We just got a separate document saying that what the dates you. This was mentioned quite generally here, right? So, then the document says what updates they are doing. VDNS number.
Yes, Swati, fine. Dheeraj, done?
Use the decimal quotation number.
Yes, ma'am.
Okay.
Yes. That's a combination of the KES, it's like KES 21 underscore.
Okay, so now we can say inbuilt array generators or inbuilt matrix generators, you can say. Used sometimes in some analysis that you're trying to perform before testing onto your actual data. If you have to do some testing, then you can work with, you don't have to sit and write or create some matrices. You can test the same by using the inbuilt matrix generators. So a few inbuilt matrix generators, what we have is you can create matrices with all zeros. You can create matrices with all ones. You can create diagonal elements, etc. So let's see few of them.
They will be generating a number.
For example, let's say we have to create a matrix with all zeros. So if I say M2 is equal to NP dot, I will call zeros matrix. Zeros as an argument, I can give the row size and column size. So if I say 5, 3, this will create a matrix with all zeros. It creates a 5 cross 3 matrix, 5 rows and 3 columns, and all the elements will be zeros. So please check.
So ma'am, is zeros a method?
Zero is the
Method?
yes.
Okay.
Now, like zeros, you can create matrices of ones. So if I say M3 is equal to NP dot ones. Once as an argument, you can give the row size and column size. So if I say ones of what to say, if I give 3 comma 5. You can also create matrices of that is your diagonal elements. That is, if I say M4 is equal to NP dot I. I matrix. I matrix means all the diagonal elements will be 1, remaining all elements will be 0. So if I say I of 5, it creates 5 rows and 5 columns, and the I matrix will be always square matrices. So square matrices means same number of rows and columns. Let me know if you have verified. Verified this?
Yes, ma'am.
Yes, ma'am.
Now let's do some linear algebra. Linear algebra means you can perform like addition of matrices, then you can perform the metric multiplications, etc., etc. So let's see a few of them. So first, let's create vectors. We will start with vectors and then we will extend it to matrices. So let's say if I'm creating a vector like this. 2 and 3. If you have to perform these operations, the two vectors should be of the same size, isn't it? Right. And we 6. So they are of the same size, right? V5 has elements 1, 2, 3, 4, and 5. V6 has elements 3, 4, 5, 6, and 7. So if I try to perform the addition, what will be your output? What is V5 plus V6?
It doesn't have an exclusion factor as it because
What is V5 plus V6?
Add indices, same indices.
That is vector addition we are trying to do. So we have the two vectors. What? We have the two vectors 1, 2, 3, 4, and 5. And the next 3, 4, 5, 6, 7. So if you add this, what do you have? 3 plus 1, 4. It adds the elements. First element of both the vectors will be added. So 3 plus 1, 4. 2 plus 4, 6. 5 plus 3, 8. 4 plus 6, 10. 7 plus 5, 30. Right? So execute and see. 7 plus 5. So this is vector addition. It does element by element and both the vectors should be of the same size. So then you can add the two vectors. Fine?
Yes, ma'am.
Verified?
Yes, ma'am.
Yes, ma'am.
Understood? Understood what vector addition is?
Yes.
Yes, ma'am.
Now, if it was product, if I have to perform the product of two vectors, that is, if I say, okay, V5 and V6, right? V5 into V6. How does this work? V5 into V6. V5 into V6. Vector multiplication. What will be your output?
Multiplication of the indices 3,
1
8,
into 3,
15.
3, then 2 into 4, 8, 3 into 5, 15, 6 into 4, 24, 7 into 5, 35. Execute and see. Correct, right? Verified? Suppose if I have written a statement like this, print, I'm saying np.sqrt. So now you know what sqrt is, right? Square root of, if I say v5, or okay, what will be your output? How is this statement processed?
It will compute square root of each element.
Computes the square root of each element present in your vector V5. So verify it. You can try with V6 as well. It computes the square root of elements present in V5 and V6. Verified?
Yes, ma'am.
If my expression was like this, what do you think the output will be? One by V5. What is 1 by V5?
1 by each element of
1
that.
by the elements. Right? V5 has elements 1, 2, 3, 4, and 5. So 1 by 1, it is 1. 1 by 2, 0.5. Then 1 by 3. Like that, it performs 1 by each element of your V5. Verified?
Yes, ma'am.
Okay. So this is with vectors. Next, we have to discuss about matrices. So that we will discuss in tomorrow's session. So tomorrow you will have the session at 11:30. Okay.
Okay, ma'am.
Okay. So we will catch up again tomorrow at 11:30. Fine, guys?
Okay, ma'am.
Okay. So just go through all these and just revise your few metrics concepts, whatever you have discussed in your high school classes. What is metrics, multiplication, etc., etc. Okay. So again, anyway, we'll discuss it in tomorrow's session as well. But it's good if you could read a few basic concepts with matrices. Okay.
Yes. Okay, ma'am.
Okay, so let's catch up tomorrow then. So tomorrow at 11:30, you will have your data science class.
Okay.
Okay. Okay, guys, then. So, bye-bye, all. Take care.
Um,
Have a good time. Yes?
Bye.
Okay, bye.
ma'am.
Yeah, bye-bye. Bye. Yeah, bye.